Hello, my name is Tabitha Ratliff, and I am presenting the first half of this week's correlate on do plant sterols lower the risk of atherosclerosis. So, quick side note, this is the first time I found a PowerPoint template that has moving pictures, and I just thought this was very relaxing and pretty to look at and tied into the plant theme this week. So, like I said, I'm doing the first half of this week's presentation. I'll be going over background information regarding cholesterol, atherosclerosis, and plant sterols, and then I'll go into the studies that I picked for this week. So, cholesterol. It's a type of lipid that's naturally produced by the liver. It's needed in the body for cell membranes to make hormones, vitamin D. So it's important to have, but you need to have the right amounts of the different types. So it travels through the body on lipoproteins because it's hydrophobic. So a lipoprotein is made out of protein and fat, and it transports cholesterol and triglycerides. So there's two different types, the HDL, which is high density lipoprotein, and LDL, low density lipoprotein. In general, we consider HDL to be good and LDL to be bad. So LDL is considered the bad cholesterol. This lipoprotein takes cholesterol from the liver and then takes it to the rest of the body, delivers it to cells. The bad thing is that if there's too much of it in the arteries, it can build up on the side walls and form plaques. So like I said, HDL is the good cholesterol. It travels through the body to the blood vessels and removes LDL from the arteries and then takes it back to the liver. So here's a chart of the different forms of cholesterol and what we consider to be ideal, borderline, and too high or low. So for LDL, we want it to be under 100. And then once it gets above 130, we start to get a little worried. And above 160 is when you definitely need to have treatment. HDL, we want it above 60, but then we have like borderline levels, and then too low levels for men and women. So the issue is a lot of people in the United States and the world in general have high LDL and low HDL. So they have a high amount of cholesterol forming plaques and a low amount of the cholesterol that clears those plaques. So atherosclerosis is plaque formation in the arteries, and this causes the arteries to be stiff and have less blood flow going through due to the narrowed lumen. So if you look at the picture on the left, you can see blood flowing through a normal artery, and then as the plaques form, the lumen gets more narrow and it eventually restricts blood flow. These plaques can cause ischemia to downstream organs, and it can also have a chunk of the plaque break off and form a thrombus that can go into the heart vessels and cause a myocardial infarction, or can go like to the brain and cause a stroke. And then the picture on the right is showing a real vessel with the plaque on there, and it just looks, fatty and not healthy at all for the vessel. So plant sterols are naturally found in plant cell membranes. So they're in the food that we eat, like vegetables, fruits, nuts, legumes, and they have a similar structure to cholesterol, as you can see in the picture on the bottom. They look pretty similar, just have some different branching chains. And there's also another type that you'll see in the studies that I'm going to talk about called plant stanols. And so plant sterols and stanols are different types of phytosterols. And the only difference really is that stanols are hydrogenated, so they don't have this double bond down in the structure. So both of them are similar to cholesterol, and they compete with cholesterol for absorption. So if you eat a meal with vegetables or nuts or something, they will block the absorption of cholesterol because they get absorbed instead. So this helps decrease the cholesterol absorption. So that leads us into the studies and why plant sterols can be useful. So the first study I'm going to talk about is the article that was posted on Canopy, and it was from 2007, so it's a little old, but still good. And it talks about how it talks about the lipid lowering effects of plant sterols in capsule form. So the purpose of the study was to determine if plant sterols in capsules lower plasma cholesterol levels in hypercholesterolemic subjects. So they hypothesized that the capsule formulation will be effective to decrease LDL. For methods, they had 16 patients total, and the study was double-blind, placebo-controlled, but not randomized. And how they did it was they had 4 weeks of a placebo, and then 2 weeks of a washout, and then 4 weeks of the treatment. So the treatment was either a placebo or the plant sterols, and they got blood samples taken also at 3 different times during each phase, so day 7, 21, and 28. The subjects were given 60 capsules for the treatment phase, and were supposed to take 2 a day, 1 for lunch and 1 for dinner, and then they had a few extra in case you dropped one or something like that. In the blood samples, they had primary measurements and secondary measurements. So for primary, they looked at total cholesterol, HDL, and LDL, and then for secondary, they looked at changes in triglycerides, and then the ratio of total cholesterol to HDL, the ratio of LDL to HDL, and then CRP, which is C-reactive protein and is an inflammatory marker. For the results, it showed that for week 3, LDL was decreased by 7%, and in week 4, it was decreased by 4%. And then for HDL, it was increased by 9% in week 3 and 4% in week 4. And then total cholesterol to HDL and LDL to HDL decreased as well during weeks 3 and 4. Total cholesterol, triglycerides, and CRP did not change. So they concluded that plant sterols in capsule form were effective at lowering LDL without changing the diet at all. So the patients were on their normal diet, and the only change was adding these capsules, and it was able to lower LDL. So they also found that you had to take the capsules with food to stimulate bile so that the plant sterols could be absorbed. There were some limitations to this study. Like I said, the patients were free living. They just had their normal lives and their normal diet. And there was no dietary record taken at baseline to see how the patients were eating before the study, or taken during the study to see what their diets were like. So some patients might have decided to eat healthier than normal because they were trying this, study intervention. So that might have, changed a few things about the results, but, and then the study was not randomized, and the way they measured compliance was by just counting the capsules. So they were given 60 for the 4 weeks, like I said earlier, and when they did their check-ins, they would just count the capsules and make sure that there was only 4 left over, and if there was less than 4, then ask like what happened to the ones, like did they drop them or something like that. So, I mean, that's not the most robust way of measuring compliance, because a patient could have, known that they were supposed to take X amount a day and just like not taken them, but taken out the capsules, or like they could have missed a few doses and just like removed those capsules once they realized it. So, okay. And then next study looks at the effects of cholesterol level. So this is a meta-analysis looking at a bunch of different studies. The purpose of this was to investigate the combined and separate effects of plant sterols and stanols on LDL levels. They hypothesized that sterols and stanols will have similar effects with lowering LDL cholesterol. And so I have the inclusion criteria below. I'm not going to go over all of it because it's quite a bit, but you can read that if you want to. So they looked at 124 studies with a total of 201 study arms. 129 had plant sterols only, 59 had stanols only, and 13 had both. That had an average of 48 subjects per study, and the average dose of plant sterols or stanols was 2.1 grams per day. So some of the studies had liquid plant sterols and others had solid. So there were 15 out of 40 of the plant sterol studies were liquid, and 4 out of 18 of the stanol studies were liquid. So for the results, it showed that plant sterols and stanols reduce LDL levels in a dose-dependent manner, and it increased LDL reduction up until about 3 grams a day, with an average of about 12% reduction. The studies that were over 4 grams per day were very sparse, and so our authors weren't able to really make conclusions about over 4 grams a day. The liquid diet decreased LDL by about 6.5% and the solid diet by about 9.2%. So they were able to conclude that sterols and stanols were equally effective, and both reduced LDL at about 12%. So the limitations and confounding factors were that some studies did solid routes and others did liquid. Some used sterols, some used stanols, and there's just variation in how the studies were set up. And then, like I said, there weren't very many studies with doses over 4 grams, so they couldn't make any conclusive remarks about those doses. The next study is about if using plant sterols or stanols in capsule or tablet form is as effective as doing a natural source like eating a plant-based diet. So they included 8 studies. The doses ranged from 1 to 3 grams per day, and I'm just going through this one pretty quick. So the results showed that plant sterol supplementation decreased LDL by about 12 milligrams per deciliter, and plant sterol enriched foods decreased by about 12. So there was no difference between the 2 different routes. And then I included a couple extra studies just to look at more information, but I'm not going to go through them very thoroughly. So this one is about other ways that plant sterols can reduce atherosclerosis. So this one looked at endothelin and other markers. So endothelin is a protein released by the vascular endothelial cells, and it is a vasoconstrictor. So it's been linked with the development of atherosclerosis because it makes the vessels more narrow. And if the vessels have plaques and things, there's less of a lumen there to begin with, and if you're constricting it, there's even less of a lumen. And it would make it easier to form a plaque and block off the artery. So for this study, they had 38 subjects with mildly high LDL, which was over 130. They were assigned to either soy milk or soy milk plus plant sterols for 4 weeks. It was a double-blind, placebo-controlled crossover study, and they did blood samples looking at lipid profile, biomarkers for inflammation, and endothelial dysfunction. So they looked at total cholesterol, HDL, triglycerides, fibrinogen, endothelin-1, CRP, IL-6, TNF-alpha, and VCAM-1. The results showed that endothelin-1 decreased by 11%. None of the other inflammatory or endothelial dysfunction markers were changed. Cholesterol decreased by 5.5%, LDL by 6.4%, and triglycerides by 8.3%. HDL did not change significantly. They looked at the change in endothelin-1
in LDL responders and non-responders, meaning patients who had a decrease in LDL with the plant sterols and ones that did not have a change, to see if endothelin 1 decreased due to the LDL decrease or it decreased on its own. And there was a change in endothelin 1 in both groups. So they were able to conclude that plant sterols lower endothelin 1 independently of LDL. So this is my last study, and I just wanted to include this quickly to show that there are some limitations with using plant sterols. So some patients just have a genetic variation that don't allow the plant sterols to be as effective. So while plant sterols have been shown to decrease LDL in most patients, some will not benefit with this supplementation. So there is some limitations with this therapy, and if a patient has that genetic variation, then it might not be the best route for them.
So in general, these studies showed that plant sterols are effective at lowering LDL. Supplementation is as effective as doing more naturally derived sources from food. And there's other avenues that plant sterols reduce atherosclerosis besides just lowering LDL. It also reduces endothelin 1. And there is some genetic variation to plant sterol absorption, so it may limit its effectiveness widespread through the population. And my partner will be talking about the rest of our studies. Thank you.